What you see here is a real example of a commit message in which a developer explicitly stating the intention of moving the method in order to improve code reusability. When you have looked at this commit message and the corresponding code changes, you might say, yes, code reusability has been improved. This might be just one commit message in your large dataset, and you would like to know how developers refactor their code to improve reusability in practice, and whether self-proclaimed reusability refactorings are actually improved. And this is why software metrics comes into play. This presentation is about better understanding how developers perceive reusability and apply it in a real-world scenario. Instead of manually checking the code to investigate such reusability improvement, software metrics can be calculated. Now, the issue is that there is nothing validated yet. In other words, many metrics claim to measure specific quality attributes, but haven't shown to do so. This is why we took reusability metrics and did our research. But will these software metrics be able to capture reusability refactoring improvements? Let's find it all. How do developers refactor code to improve code reusability? This is the title of our paper that is recently accepted at the International Conference on Software and Systems Reuse. Software reuse area is a very exciting field in which shows variety of different research published. What this research has in common is that they all present the most recent advances in the area of software reuse to promote an extensive exchange among researchers and practitioners. In this work, we collected data to validate whether reusability metrics actually reflect what developers stated in their commit message as reusability improvement. So let's continue to see what refactoring is. So refactoring is to make the software easier to understand by changing the internal structure without changing the observable behavior, so that the software is easier to understand and less expensive to modify. Let's look at the reason for refactoring specifically. First, it's improved the software design. For example, removing redundant code have the advantages of reducing the time it takes to modify the code. And the fact that the source code to be modified is in one place is a prerequisite for a good design. Second, refactoring makes your code more readable by making it easier to understand. This makes debugging easier by making your code more readable. So the benefit of design, readability, and debugging also helps not only quality but also program productivity. So typically, people when they refactor the code, they improve the design metrics or fix anti-patterns. However, we have been recently noticing that developers also mention that they refactor the code to improve software reuse, which trigger our attention to conduct a study. So refactoring for reusability is under research, especially that we have only one paper that talk about it. Here is the study called Does Refactoring Improve Reusability? It's a nice study that examines the impact of reusability on quality metrics related to reusability. Their findings show that refactoring has a positive effect on reusability. While this is a core result, We are more interested in the metrics used in this study to investigate if these metrics would be able to capture reusability improvement as perceived by developers in their commit message. So there is this paper linked back to design metrics without clearly explaining the perception. So there is no paper that talk about how developers perceive software reusability when they are refactoring their code. There is no practical evidence on how developers refactor the code to improve reusability refactoring in practice. Therefore, in this paper, we propose to investigate developer perception when it comes to refactoring for reusability. And now we do it through several investigations. We started by exploring how developers document refactoring. This way we can understand their perception or the motivation behind refactoring. And after that we can come back and support automations in more acceptable way in the future. So for the first dimension in our papers, in our research, we published two papers in which we explore how developers document their refactoring activities in the commit messages. One of the core findings in this paper is that we notice that developers state their intention or their motivation behind refactoring in their commit messages. Additionally, developers address quality issues that can be related to internal quality attributes, external quality attributes, and code smells. And reusability was one of the external quality attributes that is documented in the commit messages by developers. So our current paper lies in the second dimension, that is developer perception. And in this work, we try to investigate the relationship between reusability refactoring and the corresponding structural metrics from developer perception. So to conduct our study, we performed three-phased approach. We started by collecting open source 1,828 open source Java projects. These projects are well-engineered projects as they utilize the software engineering practices such as documentation and testing. We utilize a refactoring miner tool for mining refactoring from each project in our dataset. The result of this chart of this phase is a list of commit messages and the corresponding refactoring operations performed. In the second phase, that is about selection for quality attribute and structural metrics, we conducted a literature review in the existing and well-known software quality metrics. We extracted metrics that are used to assess several object-oriented design aspects in general and software reusability in particular. The process left us with 8 object-oriented metrics as shown in the slide. In the third phase, we generate the metrics value for reusability commits. We run the code evaluation tool called Understand to evaluate the code quality. So taking these metrics, we can now calculate the files before reusability commits and after reusability commits to see if the metrics were able to capture the improvement. As for the results, so for the first research question, we aim to compare refactoring activity and reusability commits with the refactoring activity that can be found in the mainstream development tasks. So this figure visualizes the total refactoring operations in each set, reusability and non-reusability commits. We observe that the distribution of reusability refactoring varies from the non-reusability refactoring. In fact, the top frequent types in reusability refactoring are move method, extract method, and pull-up method. For non-reusability refactoring, the top frequent types were rename attribute, rename method, and rename variable. While the move-related types were highly solicited in reusability refactoring, the rename activity was dominant for non-reusability refactoring, which was expected since previous studies which analyzed mainstream refactoring has found that renames are the most popular refactoring. Another interesting observation that we draw is the popularity of method-level refactoring, being in the top 3 most frequent reusability refactoring. The pie chart shows the distribution of code elements impacted by refactoring, and we notice that more than 50% of refactoring were performed at the method level. For the second research questions, we investigate the impact of reusability refactoring on the state-of-the-art metrics. So according to the figure, reusability refactoring has, we measure an increase in the weighted method per class, and the variation is found to be statistically significant. According to our finding in the previous slide, the extract method refactoring has been found to be very popular in reusability refactoring, and developers tend to create a new method while extracting the reusable code from the longer method. This implies the sudden increase of methods count per class. While developers are expected to keep the number of methods lower in the classes, the impact of reusable functionality from the longer classes creates free methods that can be built up to either superclasses and can be shared with all children. This explains the decrease of the coupling between objects and the slight decrease in the lack of cohesion of methods, which means that methods has become more cohesive. Similarly, we notice that slight improvement in the line of code with no statistical significance. The cyclomatic complexity has decreased after usability code changes with no statistical significance. In contrast, reusability refactoring has no impact on number of children, depth of inheritance tree, and response for a class. These results can be explained by the fact that the majority of reusability refactoring are not targeting classes. In fact, if we refer to the pie chart, only 13.3% of reusability refactoring targeted classes and extracting subclasses, which would have impacted these metrics, and so its impact is negligible. So to conclude, in this study, we found that there are a variety of structural metrics that can represent the internal quality attribute and the external quality attributes. Also, when developer refactor the code for the purpose of reusability, number of methods significantly increase. Lastly, there are some cases in which the metrics do not capture reusability improvement or capture non-significant improvement at all. This brings us to the end of the presentation. If you are interested in the dataset used in this study, or you would like to extend or replicate our study or our result, please visit our website https://smileable.github.io/self-refactoring. Thank you.